Okay, question one of the 2023 SACE General Math exam starts off with a network question. There's a network here shown, which shows the steps to assemble a children's toy. The first question says to complete the precedence table below for the network to show the prerequisites for tasks B and F. So we want to identify the prerequisite for task B and for task F. Now, because task B is coming from the start node, there is no prerequisites for any tasks that come from the start node. In fact, when you want to draw a precedence network, you would start with the tasks that have no prerequisites from that beginning or start node. So task B has no prerequisites, so we'll put none. And for task F, looking at the precedence network here, we can see that F starts at the node that tasks C and D finish. So the prerequisites for task F, or the immediate prerequisites for task F, are C and D. Moving on to the next question, it says state a task that must always lie on the critical path for this network. Now, immediately when I looked at this, I just thought straight away, well, it has to be G, because there are two ways to get through this network. We can sort of go around the top here through A and E, but you still have to get through G to finish. Or you could go through the bottom bit here, so B, D or C, F, and then through G. So you always have to go through G. So I'm going to say task G must always lie on the critical path. I am looking at one set of solutions, but I actually believe another possible solution could be task B. Because if you look at it, regardless of which way you go, with this dummy link here from task B is also a task that always must be completed as well, because B is a prerequisite for C and D, and B is also a prerequisite with that dummy link for E. Okay, so I think in the exam, either G or B would be acceptable. But looking at the set of solutions I have, it's only listing task G. Moving on to the next question there, it says, with reference to the network, explain why the dummy link is required. Now, you need to have reference to this network here in particular. Now, it says this dummy link is telling us that the prerequisite for task E is A and B. So task E has prerequisite A and B, while tasks C and D only have the prerequisite B and not A. So tasks C and D only have the prerequisite B. So I can put that there. So tasks C and D only have the prerequisite B. Okay, so make sure you get both points there and make sure you explain it with reference to the network that's drawn there for you. Okay, moving on, it asks us to do a forward and backward scan on this network. It now has some times for each of those tasks. So we'll go ahead and start with our forward scan, starting in the starting node here with 0 on the left-hand side. Now, we want to find like the longest path through, right? So from here to the end of task A, we could put a 5 there, but remember this dummy link also goes from B to this node as well. So I'll put an 8 down the bottom here. And in this in the left-hand side of this node here, I could either put 5 or 8, keeping in mind the dummy link always has a weight of 0. Okay, so I'm going to put in 8 because that is the largest number. Okay, so we can only start task E after 8 minutes. Okay, we can't start it after 5 minutes because task B must also be finished before we start task E. Now from here, let's move through either task C or D. Again, we're taking the largest number, so we're going to add 10 to my 8, giving me 18. And in the left-hand side of this node, I can have two possible solutions. I can have 18 plus 6, which is 24, or I can have 8 plus 12, which is 20. Obviously, I'm going to go with the 24, which is largest, because I can only start task G once task F is finished at 24 minutes. So 24 plus 3 gives me 27, which is my minimum completion time for the task. To do the backward scan, pretty much doing the reverse operation there. So let's change color and start with 27 on the right-hand side of the finish node. And we're just going to subtract. So 27 take 3 gives me 24. Now 24 take 6 gives me 18. Now, again, I want to take, I guess I want the lowest number to be on the right-hand side here. So 18 take 10 will give me 8, or 18 take 7 will give me 11. So I want to put in the 8, the lower number here, but that means that the latest possible start time for task D is 8 minutes, but the latest possible start time for task C is 18 take 7, which is 11. So that 11 then is shown on the arc there representing task C. So the latest possible start time for task C is 11 minutes, giving a slack time of 3 minutes, 11 take 8. And from here, 8 take 8 gives me 0. I've just gone through my critical path there. I probably shouldn't have put that one in first. I probably should have put this one in first. 24 take 12 is 12. So 12 goes there. So the slack time for task E is 4 minutes. 12 take 8. And then just understand as well that we have 2 arcs converging back to the start node. So there is no slack time for task B because that's on the critical path. But there is some slack time for task A. It is 12 take 5, which is 7. So the slack time for task, so let's fix that up. The slack time for task A is 7 minutes. Okay, so that's it. I've done the forward and backward scan. And the last question just for question 1 says to state the minimum completion time for this network, which is 27 minutes. So that's it. 27 minutes is the minimum completion time, and that's question 1 of the 2023 exam. If you wanted to look at the critical path here, obviously you would follow the path where the earliest start time and latest possible start time are equal. So the critical path, let me just quickly highlight that there for you, is task B, D, F, and G. Okay, understanding that obviously those 2 values inside the nodes are the same along that critical path, and any delay in any of those critical tasks will increase that minimum completion time. That's it. Thanks for watching.